Hello, you're watching section 6.3, rate of change. Your rate of change is a rate that describes how one quantity changes in relation to another. Another word for this is slope, and Mr. Kohler and I will do more with slope in the following week. Okay, so this is just kind of an introduction. I'm showing you through tables of actually different proportions, different ratios, how the rate of change is formed. So your slope is a rate of change between 2 points on a line. And all of these, whenever I figure out a rate of change, we're going to be using the formula for slope, which is the change in y, the vertical change, and vertical, remember, goes up and down, over change in x, the horizontal change. Okay, the formula that correlates to this, because it's 2 points, is the 2 points on the line, and we're talking about a coordinate plane here, where this is x and this is y, okay, is going to be the change in y. So what am I doing from one point to the x? How is it changing vertically? Okay, so I'm going to take this point, which we call x1, y1, just meaning it comes from the same point, and this point is called x2, y2. And basically what you're doing is you're finding the difference between the y's. So the difference here would be that vertical change. So I'm taking this y minus this one. Okay, and then I'm doing the same thing to the x's. I'm taking my x1 minus my x2, or vice versa. Okay, because then I want to know the change horizontally. Okay, what's important here is that we make sure that when we subtract our two coordinates, that if I put my y2 first, this coordinate, from this y coordinate from this total ordered pair here, that y2 goes first, then that same x from that same ordered pair has to go underneath that. It has to be what you're subtracting from in that problem as well. So we want to make sure the 2 is lined up with the 2 here, and the 1 is lined up to the 1. These are called subscripts. They are not exponents at all. We're not using exponents. This is just showing you that this x and y come from the same ordered pair, and this x and y come from the same ordered pair. Okay, so once again, we're finding our vertical change first. So we're subtracting the y's. That's our vertical change on the y-axis, up and down. Over the horizontal change, that's my x, because the y-axis goes right or left. Okay, horizontally. All right, and as we go through, this is going to make more sense. As we do more work with slope within the classroom, this is going to make more sense as well. Okay, so we need to do our best we can to make sure we understand this relationship. Okay, so the table shows the number of miles a plane traveled while in flight. Use the information to find the approximate rate of change in miles per minute. Okay, so miles is going to be on the top, per minute is on the bottom. So we're going to say this is our x and this is our y. Miles on the top, per minute. Okay, so we're doing change in y, which is the miles here, because that's the top number, over change in x, which is the minutes, okay, because this is telling me how to set it up. Miles per miles over minutes. Okay, change in y, so change in miles, over change in x, which is change in minutes. So what you need to do is find two ordered pairs. Okay, now these correspond to one another. My pen's not working again. Be patient with me here. Okay, these correspond to one another. The 30 and the 290 correspond. Okay, as do the 60 and the 580, the 90 and the 870, the 120 and the 1160. These are my x's and y's. So I actually have four ordered pairs here. You are going to choose whichever one you want. Okay, you're going to choose whatever ordered pair you want. So I'm going to choose this one and this one because it doesn't matter which ones I choose. I'm going to hope my pen works. So my two ordered pairs are 30, 290. and 60, comma, 580. Okay, these are my x, and this is the y. Okay, it doesn't matter which ones you choose. You're just going to choose any two. Okay, once again, does not matter which ones you choose. Okay, so since my change in y goes on the top, I'm going to take my y coordinates here and I'm going to subtract them from one another. You can either take 290 minus 580 or 580 minus 290. Since I'm going to take the larger number because I want a positive answer, but you could do either way. Now, because I put 580 first, the 60 has to go directly underneath it because this is the y and the x from the same ordered pair. So I'm going to take 60 minus my other y, which is, or I'm sorry, x, which is 30. Okay. So once again, you can use your calculator if you need to. So 580 minus 290 is 290. Okay. 60 minus 30 is 30. So that means you're going 290 miles per 30 minutes. Okay, because the y is the miles, the x is the minutes. Okay, it says use the information to find the approximate rate of change in miles per minute. All right. So since we want to find it miles per minute, we're going to go ahead and change this to the unit rate. So I've subtracted my y's, I've subtracted my x's, now I want to change it to the unit rate. So to do a unit rate, we're going to divide by 30 because you want it per 1 when we do the unit rate. Okay, so your answer should be as a unit rate. So I take 290 divided by 30, and once again, I'm using my calculator. You can always use your calculator now. So 290 divided by 30 is actually 9.6 repeating. Okay, so I'm just going to go ahead and put 9.7 miles. Okay, and then I'm going to take 30 divided by 30, which is 1. So 9.7 miles per 1 minute. Okay, and that's my answer. So I've used my rate of change to do the change in y over the change in x. And then my final answer should be in unit rate form, meaning it's per 1. So I'm going 9.7 miles per minute. Okay, so let's try another one like this. Table shows the number of miles a car drove on a trip. Use the information to find the approximate rate of change. Okay, so this is x. Oh my goodness. Sorry, this isn't working out very good. Okay, so approximate rate of change. We want to know miles a car drove on a trip. So this is my miles, and I want to know how my per hour. I want to know how many miles I'm going per hour. So this is my x. Oh, I'm going backwards. If I want to know miles per hour, then this is actually my y. And this is my x. Okay. Okay, so I'm going to pick my two coordinates again. So I have a time of 1. I'm just going to pick the first two. So my x is 1. And my y is 65, okay? And once again, we determine the x and the y but according to what the rate is. So I'm going miles per hour, which means the y would be the top number and the x would be the bottom. And then I have 2 hours and 130 miles. Okay, so we're doing change in y, so I'm going to do 130 minus 65, and then once again, the only reason I'm putting my 130 first is because I personally want a positive number. So 130 minus 65, and then since I put the 130 first, I'm going to put the 2 underneath it and get 2 minus the other x value, which is 1. So 130 minus 65 is actually 65. 2 minus 1 is 1. And this is 65, and look what that represents. My y's represent miles. And my 2 minus 1, my 2 and my 1 represent the hours. Okay, and once again, you want your answer as a unit rate. But because I already have a 1 as my denominator, I'm done. Okay, so because it's already per 1, that's what I want, there's my answer. So my answer is 65 miles per hour. Okay, there's my answer. You want it to be per 1. Okay? It says the graph represents the distance traveled flying in an airplane. Use the graph to find the rate of change. Okay, so rate of change, once again, is change in y over change in x. And you should not be trying to write anything down right now. I just want you to pay attention. You can pause it and write this picture down, but I want you to make sure you're paying attention right now. So stop writing if you're writing. Okay? So you're going to look at each ordered pair individually. Okay? So I have 3 coordinates on here. The first coordinate is at 1, 300. The second is at 2, 600. And the third is at 3, 900. Now what's nice about it already being on a graph is that you can just do some counting. So I'm going to start here and I'm going to do my change in y, which is, we said, the vertical change. So I'm going to go up from 300 to 600, 100, 200, 300. So I went up first, 300. So that's going to be the top number, 300. Okay, and then I'm going to go my horizontal change. So I'm going to go to the right over just 1 to 2, so 1. So I did 300 miles. This is miles. Okay, and this is my hours per 1 hour. Okay, make sure when you're going a horizontal change, you're counting, or I'm sorry, vertical change, you make sure you're counting by whatever the units are on the side. So I went 100, 200, 300, then I went over 1. You could also do it from the next one. Start here, and I'm going to go up 100, 200, 300. It's the same thing as my vertical change. My change in x, my horizontal change would still just be 1. So you're going 300 miles per 1 hour. Okay, once again, it says find the slope. Explain what the slope represents. So your slope is the same thing as your rate of change. Okay, so this is my x and this is my y. So I'm going to pick 2 ordered pairs. So I have 345, 690, and the last one is 9 and 135. You're going to pick any 2 you want. So I'm just going to pick these 2 right here. So I'm going to take my change in y, which would be 90 minus 45. Since I put 90 first, the 6 has to go underneath, and it's 6 minus 3. So 90 minus 45 is 45. 6 minus 3 is 3. And then I'm going to simplify, and I can divide these both by 3. 45 divided by 3 is 15. 3 divided by 3 is 1. Okay? It says, what does this represent? Well, the 90 and the 45 represent amount earned. So this is money. So $15. The 3, the 6, and the 9 all represent hours. So this means that you're making $15 per hour. So when it asks you to find the slope and explain the meaning, what you're basically doing is putting units with your answers. Okay, your units, just like in your rate of change, are going to tell you what's happening to the y value, how it's changing, over how it's changing in the x value. Okay, this section can be a little bit confusing, so if you get stuck and you've taken all your notes and you're not comfortable starting the homework yet, tomorrow you're going to watch me teach this, or Mr. Kohlinger teach it again. Okay, that's just going to help you understand it even better. Okay, and get your questions answered. Then if you feel comfortable even halfway or partway through the lesson, then you can start your homework. But we don't want you to start your homework until you feel 100% comfortable with this section that's just been taught. Okay, so as always, if you have questions, ask Mr. Kohlinger or myself tomorrow. Thank you for watching. We appreciate it. And see you tomorrow.